Dear friends, good evening. We wish to thank you for attending today's public lecture entitled Climate Change, From Doubt to Evidence, Global and Regional Aspects by Dr. Michel Jarraud, Secretary General Emeritus of the World Meteorological Organization. I would like to invite to the podium Mr. Muriel, Director of the French Institute, to open tonight's lecture on behalf of Her Excellency, the Ambassador of France.
Kalispera σας. Mr. George Vassiliou, former President of Cyprus, Mr. Kyriakos Kokinos, National Chief Scientist for Research and Innovation, Mr. Timo Eno, Ambassador of Finland, Mrs. Ambassador of Netherlands, Mrs. Androula Vassiliou, former European Commissioner, Mr. Georgiou, Permanent Secretary of Defense Ministry, Mrs. Dora Shimonidou, Director of Agricultural Research Institute, Mr. Pedros Cariclas, Mayor of Israel, Professor Zhang Jie, Director of the Energy, Environment and Water Research Center, Kalispera σας. I'm the new director of the French Institute and advisor for cultural affairs of the French Embassy. Dear friends, Imer harumenos pou vriskome anamenasas simera. Then I will continue in English. This project that we are going to launch tomorrow, which have received funding from the European Union, is a real testimony of the involvement of Cyprus in the struggle against climate change and on environmental issues. As you know, France has played an important role in the struggle against climate change, notably in formulating the Paris Agreement in December 2015, in the frame of COP21 in Paris, under the presidency of Laurent Fabius, foreign French minister. In May 2018, Mr. Fabius was here in Cyprus, where he participated in the International Conference on Climate Change in the Mediterranean and the Middle East, which was held here in Nicosia and organized by the Cyprus Institute. On this occasion, he underlined that Cyprus and all the region were particularly concerned by climate change effects and that we have all to do more in that field. And last spring, Mr. Fabius was also here in Cyprus, where he was awarded the title of Honorary Doctor of the Science of Law at the European University of Cyprus. On this occasion, he called for a new alliance against climate change. Therefore, let me remind you in a few words the urgent nature of the fight against climate change and the need to focus on environmental challenges. Climate change is something which already affects us and will affect us more and more if we do not find a way to reduce carbon emissions. It is our responsibility toward present, but also future generations, to save environment and reduce carbon emissions. It's a question of survival. But by ending my intervention, I would like to be a little positive. For example, I would say that as other states, France has done progress, limited progress, yes, but progress. Just one example, the part of sustainable energy within the energy consumption is getting more and more important in France, passing from 9% in 2006 to 16% in 2016. I hope I do not mistake, with an objective of 20% in 2020. This is the first step. Other example can be quoted in matter of protection of environment. Just an example, for example, last year, a French team composed of 4 young French launched the said Plastic Odyssey project. It aims to reduce plastic waste in the ocean and alleviate the poverty at the same time by recycling plastic. And Cyprus should be a step during the long travel, which will be done by the team in starting 2020. So I will now leave the floor to the real specialists, and I wish you a very interesting moment and a very interesting discussion. Bonsoir.
Thank you, Mr. Mouriez. It's an honor for us to invite Mr. Kyriakos Kokkinos, Chief Scientist for Research and Innovation, for his welcoming address.
Your Excellencies, dear members of the Board of Trustees of Cyprus Institute, dear friends, welcome to this most interesting lecture from a very distinguished speaker. It is a great pleasure to welcome you all in today's public lecture organized by the Cyprus Institute. The lecture is organized within the context of the public launch of the EMECARE, standing for the Eastern Mediterranean and Middle East Climate and Atmosphere Research Center, the new Center of Excellence of the Cyprus Institute, committed to advancing research and innovation on environmental challenges. It is our honor to host today our distinguished guest, Dr. Michel Jarraud, Secretary General Emeritus of the World Meteorological Organization, WMO. With great interest, we will see today how climate science can inform policy and decision-making in all contexts, from global to regional and local, and within the context of a changing climate. Through a historical perspective, we will be informed how the United Nations, IPCC, process developed in order to make available the most authoritative information with respect to climate change. Furthermore, we will view the anthropogenic contribution to it, as well as the necessity, and I dare to say extreme urgent, to deal with both mitigation and adaptation aspects. Dr. Jarraud is a distinguished scientist and meteorologist with degrees from the prestigious French École Polytechnique and the École de Météorologie Nationale. Throughout his professional career, he served at a wide range of scientific and research positions relating to numerical weather prediction and mathematical modeling of the atmosphere. He worked for Meteo France and the European Centre for Medium-Range Weather Forecast UK. For about 20 years, he served at the World Meteorological Organization, holding the position of Deputy Secretary General and later that of the Secretary General, where he also chaired the UN Water Coordination Body for all water-related matters in the United Nations system. Since 2016, Dr. Jarraud holds the position of Secretary General Emeritus of WMO, as well as honorary positions in universities around the world, including China and Armenia. It is our honor and pleasure to host Professor Jarraud at the Cyprus Institute, once again. An organization built since its very first beginning on the core values of scientific and academic excellence. Today's lecture will be followed tomorrow by the official public launching of the ceremony of MEKR, one of the 4 centers of excellence in Cyprus, succeeding in the recent call for proposals of the European Commission Horizon 2020 teaming program. MEKR is established as a world-class research and innovation center focusing on environmental challenges, providing scientific, technological, and policy directions and solutions. The center provides for the upgrade of the existing atmosphere and climate division of the Cyprus Institute and the strengthening of its partnership with world-renowned institutes. Its research will focus on the atmospheric environment, aiming to address climate change and air pollution aspects. The center aspires to play a key role in establishing Cyprus as a leading scientific and research hub for climate change and the environment in the region, and in promoting our country as an ideal testbed for the development of critical innovative environmental technologies and solutions. At the same time, the establishment of the center reflects the Institute's commitment to support the implementation of national policies and initiatives, such as the President of the Republic's Regional Climate Change Initiative and the National Energy and Climate Plan of Cyprus, covering the period 2021-2030. Being a member of the Board of Trustees of Cyprus Institute, I am particularly proud for the achievement of the Institute since its establishment, and I am sure we will see more in the years to come. Having said that, I will give the floor to Professor Jarraud for his inspiring lecture, Climate Change from Doubt to Evidence, Global and Regional Aspects. Thank you very much.
Your Excellency, President Vassiliou, Commissioner Vassiliou, Excellencies, Ambassadors of Netherlands and Finland, distinguished members of the Board of Trustees of the Cyprus Institute, Monsieur le Directeur de l'Institut Français, Mr. Permanent Secretary of the Ministry of Defense, Mr. National Chief Scientist, for Research and Innovation for the Republic of Cyprus, distinguished guests, dear colleagues, and I should say for many of you, dear friends. I was very happy to give this presentation because I'm sure you have all been through this situation where you have heard many things about climate change and the opposite. Many scientists in the room know as much or more than I do on that, but I also wanted to go back to some of the basics and to clarify what are some remaining questions from what are some really strongly established facts. Now, the first thing I would like to do is to maybe talk a little bit for a few seconds about the difference between weather and climate, because often you hear these voices saying, but why do you worry about the 2-degree climate change, while the weather between this morning and this evening, the difference will be much more than that, or from year to year you can have cold years, you can have warm years. So the weather is really about what you get now, and the climate is an average over a long period of a number of parameters which are important for us. The temperature, but also precipitation, the wind. And the climate system is the result of very, very complex interaction. It's not only in the atmosphere. Actually, the atmosphere is only a macroscopic, a tiny part of the climate system. You have also to look at the ocean, at the cryosphere, the biosphere, at many other aspects. So when you talk about climate change, it's really a matter of timescales. On which timescales are you looking at? And it's not only about averages, it's about the variability around these averages. You see, I'm sure you have heard this thing, but we had ice age in the past, we had warm periods. Yes, true again. And the climate has kept on changing for many, many reasons, and since the beginning of atmosphere on Earth. Some of the reasons are movement of tectonic plates, but we are talking millions of years. You are not talking a few decades. You can talk about solar activity. Yes, the sun goes through some sort of cycles. One of them is almost an 11-year period. But this is small, the influence of the sun on this time scale compared to what we see now because of human influence. Volcanic activity nowadays is mostly short-term. You can have big volcanic eruption reducing temperature for a while, but not for more than 1 or 2 years. It's really short-term compared to what we are looking at. Astronomical parameter has been the main driver of the changes between ice ages and when most of Europe was under ice and warm period like the one we have now. And it's due to modification of the way the Earth is rotating around the Earth. It's not a circle, it's an ellipse, more or less elongated, like this toy for children, the spinning top, the angle is not constant, it can vary like this. All that is the main driver for the alternance between ice ages and warm periods. So we are not talking about something happening over decades, over 2 or 3 generations, like what we have now with climate change. How do we know all these things? Well, we have a number of records. Over what we call modern observation period, we are using a range of instruments. We have also, of course, the traditional instrument. You have all seen these little white boxes measuring temperature, rainfall, many things. And we still use them because they still give very important information. At the same time, we make use of almost anything which carries information on these weather and climate parameters. So we have radars, we use information from the planes when you take the plane, we have automatic weather station, we have a range, I'm coming to that, a range of satellite information from ships. Even when you use your mobile telephone, the signal which is used by the telephone is modified by humidity, and we can invert that information to derive information on precipitation and humidity. So we use almost anything which is possible. But we have also increasingly a constellation of weather, climate, and other research satellites which provide information on many things. The satellites are very useful, but they do not replace conventional observation. You need both. They complement each other. Now, for a long time, a big sort of uncharted place were the oceans. Because from satellites, from ships, you essentially can measure the surface of the ocean, but the satellites don't see under the surface of the ocean. So together with UNESCO, WMO has coordinated the installation of a network of buoys over the ocean. Actually, they're not buoys. They're like these toys for children where you put them on water and they can dip further down and then they go back to the surface. So it's exactly the same principle for these instruments over the ocean. You make them measure the surface parameter, then they go down up to 2,000 meters. So when going down, you measure all the vertical structure of the ocean, then you let them drift. By the way, you measure the currents by doing that, and then they go up again, and when they are at the surface, and they measure all the parameters on the way up, and when the surface, they send information to the satellites, and from the satellites, it's sent to all the weather services of the planet, like the one you have in Cyprus, the Met Service of Cyprus, and it's exchanged amongst all countries of the planet. So these are the modern thing, and for the first time over the last 20 years, we have managed to get a good knowledge, three-dimensional knowledge on the structure of the ocean, which is, and I will explain to you why in a minute, why it's so critical for the climate system. But when you go back in the past, we are using information from almost anything which has been influenced by weather parameters and which is leaving a trace, like ice cores over Antarctica, like sediments, like tree rings, like corals, like so many things where these processes are influenced by the weather. You can retrieve information. Of course, the further back you go, the least precise the information. But still, it is information. Some of this information, and I will show you in the next slide, is actually very precise. This is the ice core you can drill over Antarctica, and because the ice has accumulated over thousands, tens of thousands, actually hundreds of thousands of years, you can, from the analysis of the air bubbles contained in the ice, you can reconstruct the concentration of greenhouse gases up to about nearly 1 million years ago. And the result of that is actually fascinating. And this is the bottom left figure. You see over the last 800,000 years the variation of the concentration of CO2 in the atmosphere. And again, remember, this is not just some crude approximation. This is very precise measures derived from the chemical analysis of these air bubbles. So very precise information on this concentration of CO2, and it has fluctuated. Basically what you see is very much connected to the alternance of ice ages. But recently, look at the right. It's not an error on the graph. This is what we are observing now. So we are way out. So when you hear skeptics, sorry, this is nothing to do about whether you believe or not in climate change. This is something we can measure with great accuracy. And the laws of physics are what they are. You cannot tamper with them. If you have more greenhouse gases in the atmosphere, there can be only one result. The atmosphere, the climate system, is getting warmer. It cannot get colder. It can only get warmer. By how much, where, geographical distribution, we shall come back to that. There are some interesting questions. But this is fact. This is not just guessing. More recently, and these are the graphs on the top left, these are similar evolution since 1985 for CO2 on the left. So you don't see any sign of things leveling off. So the concentration keep on increasing at roughly the same rate for CO2 on the left, and for methane it's a bit less like a straight line, but still concentration of methane also increase. On the right, the graphic is also interesting. This is the contribution of the various greenhouse gases in the atmosphere to this warming. And the blue one on the top is CO2. So you see, CO2 is the elephant in the room. The other ones are important. The green one underneath is methane, so it's certainly very important as well. A bit less than CO2, because the concentrations are significantly less than the one of CO2. The one, I don't know how you see it from the back, probably some dark pink or violet color. It's nitrous oxide. It's something which is very much linked to, in particular, agriculture practices. And this one is also not negligible. The others are far from negligible. The one on the bottom, they are small, but they are increasing. And unfortunately, some of these gases stay in the atmosphere for very, very, very long period. For CO2, you are talking of the order of 100 years. For some of the little one at the bottom, it can be thousands or tens of thousands of years. For some of them, there's virtually no chemical process to destroy them, for some of them. Methane, it's a bit less. Now, who are the culprits? So what I use here is, you have seen this kind of picture, I'm sure, where you modify the surface of the country according to some parameter. So in this case, it's according to their emission of CO2. So you see China now is emitter number 1 of CO2, followed by USA. You see Europe, a big emitter, Japan. India is certainly, the emissions are increasing. And you see the contribution of Africa is very, very, very small, which doesn't mean that they don't suffer from climate change. But they don't contribute very much, but they are unfortunately for them, on the receiving end. So they will have to make significant, they will need to have significant activities to adapt to that. Now, some of the bad news, and this is what is put at the bottom of this graphic, is in 2015, 2019, so this is after the Paris Agreement. 2015-19, the CO2 global emissions have gone up by about 20% compared to the previous 5 years. So you see, we are not leveling off. We are still, it's still business as usual. Actually, it's slightly worse than business as usual. So this is a very worrying message, and this was a message which was made available to the Climate Summit, which took place recently in New York. Now, the context indeed is complicated, because most, as you know, and Cyprus is no exception to that, most human activities are weather or climate sensitive. And the vulnerability to the extreme events, as well as the economic impact, is growing in almost all countries. This is made more complicated by other factors like demography. Of course, if you have to deal with we have now more than 7 billion people. If we have to deal with 20 billion people, the situation will be significantly more challenging in many respects. Urbanization is a factor which is changing very rapidly. You know, very soon a majority of humankind will live in urban environment. In a sense, it's both part of it can be part of the solution, because some solutions may be more easily implementable at an urban level than they are in a more scattered level. But still, it's something we have to take into account anyway. And the world, and you know that well, in your part of the world, it's not immune to that. The world is facing multiple crises, which are often interconnected. Economic crisis, financial crisis, food crisis, health crisis, refugee crisis, and the list could go on and on. All these crises, without exception, are also interacting with climate change. I'm not saying climate change is producing them, but take migration, for example. The problem of migration is made worse with climate change. Some of the countries where the migrants arrive are already facing very difficult situation, and take, for example, Jordan, which has a huge number of refugees. It's a water-stressed country, and climate change is making this stress even more critical. The pictures are just two recent examples. Bahamas after Dorian, and the bottom one has been a very significant drought in India. So these are pictures from this year. I had plenty of choice. I could have selected many, but unfortunately. Now, where are we? What do we know about climate change? You might have seen a variation of this graph. This is on the top left, the evolution of temperature since we have modern records, that is middle of the 19th century, since we have a global coverage of temperature, thermometers, and a few other instruments. So this graphic shows that there is a lot of variability from year to year, and this variability until, let's say, the middle of the 20th century, you could really argue whether there was trends or whether it was just natural variability. And then afterwards, from the 1970s until now, you see the curve is going up and up and up. Some people have been, yes, there's a light. Some people have been, some of the skeptical voice have been arguing in the beginning of this new century that the climate had come to a pause. There was no climate change any longer. What they were doing, if you see this little red light, they were starting from this point, which is the year 1998, which was a year with the strongest El Niño phenomena in the last century. When you have an El Niño phenomena, it tends to warm the atmosphere. So they were starting from this point, which is the warmest year, and they were looking at that short period, and they were saying, look, there's no trend. I'm sorry, this is not science. This is manipulation of data. What you should look at now, look at the averages over 10 years, which is what you have here. You see every decade over the last 50 years has been warmer than the preceding decades. if you do what we recommend in the World Meteorological Organization to look at even slightly longer period, 30 years period, this is there, and you see every 30-year period actually since the beginning of the 20th century has been warmer than the previous one. These are the facts. This is not guessing. So there is no climate pause. There's no climate hiatus, whatever you have heard. These are the facts. This is measured with modern instruments, and you can have great confidence in these data. But something else that you need to look at is, to keep in mind, is that the atmosphere is a tiny, tiny part of the Earth system. The atmosphere is important for us because we live there. This is, for us, it's essential. But for the planet, for the climate system, about 93%, over 93% of the extra heat due to this greenhouse gas in concentration increase is actually stored in the ocean. Only about 2.3% in the atmosphere. So in a sense, the atmosphere is only a tiny fraction of that. And you could have actually warming of the ocean, and sometimes you can see, for a short while, cooling of the atmosphere. But the climate system is increasing. On the right, you see the increase in the heat content of the ocean. And both it is the upper ocean in light blue, the deep ocean in dark blue, and you see very worryingly the heat content of the ocean is increasing very significantly. Other thing which absorb part of this extra heat, the continent about 2%, the glacier, all of them together about 2% as well. So, but the bulk of the extra heat goes into the ocean. In a sense, it's good because it means that the inertia of the ocean saves us from something running completely out of control. However, it has a number of effects. Sea level rise. I will come to that in the next slide. Acidification, melting of the Arctic ice, and a decrease in oxygen content of the ocean. In addition, the ocean absorbs a significant fraction of the CO2, about 25% on average, but at some stage you may reach a saturation point. So we have to be very, very careful with this issue. Now, back to sea level rise. You have essentially three components to sea level rise. One of them is melting of the glaciers over land. The one over water, over ocean do not matter. The one over land. You have also the warming of the ocean itself, and the water, like many bodies, when it gets warmer, expands, so that contributes to sea level rise. And you have also some other cause contributing less, but still contributing, like when you use underground water from fossil underground table, they eventually end up either in the atmosphere as evaporation or in the ocean through the rivers. And that does contribute a little bit to the sea level rise. But the two main contributions are expansion of the water and melting of the land glacier. Now, what do we observe? And again, by the way, we have these figures with incredible accuracy because we have satellites which can now measure within a fraction of a millimeter how the sea level is rising. Over the 20th century, the average was less than 2 millimeters per year. Now, over the last 5 years, this is a very recent figure from a recent report by IPCC just released in Monaco a few weeks ago. It's 5 millimeters per year. So it has more than doubled. So this is extremely worrying. And the impact, you are familiar with the impact, some of them actually in Cyprus, but in many countries you have coastal erosion, you have intrusion of salted water in underground freshwater table, you have the impact of storm surges are bigger than tsunami. Tsunami is nothing to do with climate change, but when you get a tsunami and if the sea level is 40 centimeters higher than it used to be, the tsunami has more of a devastating effect. It's just a mechanical consequence of sea level rise. So all that are of great concern. Arctic ice is melting. This is, again, very recent picture. I just got it before leaving. The day before I left, I took this picture on the right. This is at the end of September. It's from the US Ice Center. And it's the extent of sea ice in the Arctic. You see blue, you can no significant ice when it's blue, and white is what is still completely ice. And you may, I don't know whether you can see from a distance, there's a yellow line which is here, and that was the average over the last 30 years. So it is dropping by about 13% every decade. Now, this is important for many reasons. Some, you may argue, is positive. You will be able to navigate north of Siberia. Okay, that may be good news. But at the same time, when you see ice from the space, it is white. It reflects radiation from the sun. When it's melted, essentially the ocean is dark. It's black. It absorbs all the heat. So the more it melts, the more it contributes to warming. So it's an amplifying effect. Now, how do we? What did we do as a scientific community to alert the Mr. President, you decision makers at all levels? So it started essentially, the first warnings started in the 1970s, where through the measure we could observe a significant rise in some greenhouse gas concentration. But at the time, you may remember, it was Cold War context. People were worried about nuclear winter. They were worried about a number of things. But it was very difficult to convince people that climate change was a serious issue to consider. And to be fair, the signals we were observing were significantly weaker than the natural variability. But as time was passing, after WMO issued the first declaration on greenhouse gases, it was 1976. We organized the first World Climate Conference in 1979. There were a few big steps. There was still in the 80s many scientific discussion about the reality, the risk, and in order to try to give an authoritative perspective on that, WMO and UNEP, the United Nations Environment Programme, together created what is now known as IPCC, the Intergovernmental Panel on Climate Change, which every 5-6 years issues this big report, what is the state of knowledge with respect to climate change. And then there was the Earth Summit in Rio in 1992. There was a number of events. I don't want to name them all. The 90s, because some people, the scientific committee got really worried, a number of decision makers got worried as well, but at the same time, a number of people didn't want to face the reality. And the skeptical voice, also, there was a big rise in the skeptical voice in the 90s in particular, probably culminating in the Copenhagen conference in 2009, where that was probably the culminating point. Since then, these voices have diminished. However, they are still, to my taste, they are still too strong, and often I fail to fully understand why we have failed to convince people. So obviously we need to look at ourselves. Obviously our communication efforts were not appropriate, but we need to do more to convince people of the reality. We were very happy, and the scientific committee was very encouraged in 2007, where the IPCC got the Nobel Prizes. So here in the room, you have many Nobel Prizes winners. In the institute, you have many of the scientists contributed indeed to this Nobel Prize. So it was a big encouragement. It was not an individual person. It was shared with Al Gore. But for the IPCC, it was a collective Nobel Prize. And it was a very strong encouragement for all the scientists that their work was appreciated as a contributor to peace and in the world. Now, my conference is entitled From Doubt to Evidence. So I wanted also to review a little bit the evolution of what we have known on these things. And I'm basing it on the successive IPCC reports, AR 1, 2, 3, 4, 5, AR assessment report. So from 90 was the first one. And at that time, what about the reality of climate change? At that time, we estimated that the climate had warmed by something like 0.3 to 0.6 degrees globally since the middle of the 19th century. But the signal was similar or even weaker than natural variability. 95, not much change in this range. I will say in the next slide something about attribution to human activities, but it was the same range. Third report, 2001, now you can see the range has increased slightly, 0.4 to 0.8. And the 90s were the warmest decade we had ever observed since we have modern records. Fourth report, 2007, 0.6 to 0.9. So you see, the thing is increasing. And the conclusion of the report was that the warming was unequivocal. Very strong words. 2013, the climate is warmed by 0.7 to 1.1. Again, we are getting higher. The warming is still unequivocal. You cannot have more than unequivocal. And the period 1983 to 2012 is likely to be the warmest 30 period over the last 1,400 years. Forget about the medieval optimal. So this is the most, globally, maybe locally you can have warmer periods, but globally this is the warmest period for a very, very long time. So this is about the reality of climate change. The doubt is no longer allowed. But what about the attribution to human activities? Going through the same sequence. First, assessment report 90, attribution difficult. So we are not quite sure. Scientists are honest people. They don't, often they are maybe not strong enough in the messages. You can blame them for many things, but not for overstating the facts. Rather, you can blame them for underestimating, being too cautious. But 1990, attribution difficult. 95, aha. Now there was a real change, real breakthrough in the science. The balance of evidence suggests a discernible human influence. So we couldn't say it's due to, but the various evidence was pointing definitely towards human influence. 2001, there is new and stronger evidence that most of the warming observed over the last 50 years is indeed attributable to human activities, with a likelihood of over 60%. 2007, same conclusion, but now very likely, 90% probability. And 2013, the last assessment report, it's extremely likely, now 95%, that human influence has been the dominant cause of the observed warming since the middle of the 20th century. So you see, every report comes with a stronger message. But of course, the signals, the science has made progress, and at the same time, the signals are getting stronger and stronger. This is what we know now. What about the future? The future, here, I've extracted that again from the last assessment report of IPCC, and this is the expected temperature changes at the end of this century with two different scenarios. On the left, it's assuming you have a sort of best case scenario, optimistic scenario, where we take very strong action very quickly, and you would get the warming on the left. By the way, everything which is yellow turning to dark brown is warming, and the darker it is, the stronger the warming. On the right, the same thing, same period, but with what was called at the time a sort of pessimistic scenario, the worst case scenario. Unfortunately, since the beginning of the IPCC, the worst case scenarios have turned out to be the one that we observe. So we are not on track for the left for the time being, but we are rather on track for the worst case scenario. This is temperature, but similar worrying graphic you could show for precipitation. This is on the top. Now yellow and brown correspond to drying, blue and dark blue correspond to more precipitation. But the message in a sense is very simple. In places where you have already water stress, it's likely to get worse. In places where you have already too much water, you are going to get even more water, and probably in the form of extreme precipitation. So translate in normal language, more risk of floods on one side, more risk of heat waves and drought on the other extremes. The bottom one, I'm sorry, the contrast is not very good, but it's the same graphic for sea level rise, and sea level rise is not going to be uniform either. But again, there can be very significant differences between the various scenarios. So this is the global picture. What about the some regional aspect? And here I want to thank, I think he's in the room, to thank Jos Lelivel, because he gave me the next slide. So thank you. If I'm saying something wrong, I'm talking under your control. you can correct me. So these are the expected changes in the region, in a large sense, the Mediterranean region. And this is an outcome of something coordinating under the auspices of the World Climate Research Programme. And this is showing the summer maximum temperature and the various IPCC scenario. On the left, it's by the middle of the century. On the right, it's by the end of the century. This is for summer, and you have a sort of optimistic scenario on the top, worst case scenario on the bottom, and middle scenario in the middle. Well, the message, it speaks by itself. That is, it's certainly going to be easier to adapt to the top situation than to adapt to the bottom one. The bottom one is likely to have devastating effect in this part of the world. Another graphic, which is for Nicosia, and Jos, thank you again for this graphic. This is for the middle scenario, which by now I would call almost an optimistic scenario. These are the probability distribution of maximum temperature in summer in Nicosia, different time periods. The blue line on the left, with an average of, I think, about 35 degrees, is for the period 1961 to 1990. Then 2010, 2039 is the next line, and then 240, 269 the next one, and the right one is 270, 299 at the in the violet. You see the shift in the top. The most likely sort of temperature is about 4 degrees, 4.5 degrees, but in summer in Nicosia, you are living there. You know what it means to add another 4 to 5 degrees in summer in Nicosia. This is not good news. I'm sure you will agree with that. Now, if you look at other regional aspects, it's similar to the previous, the one I showed earlier. Again, thank you, Jos, for this slide. It's for precipitation for the wet season. So very much similar to one for temperature, but for precipitation. So remember, top graphic, best case scenario, optimistic scenario, middle scenario, and the bottom is the worst case scenario, which is now probably close to business as usual. And on the left by the middle of the century, on the right by the end of the century. And you know where Cyprus is, and so it is not good news in terms of precipitation. Now, we still have a choice. We still have a choice, but time is running out. In a sense, you can consider CO2 concentration in the atmosphere a little bit like what we can still emit to keep the situation manageable. It's a little bit like money in your purse. You have a certain amount of money, and when you have used it, there is no money left there. Here, we still have a little bit of a flexibility. You can still emit a little bit, but at the same time, as time is passing, this thing is running out. So we need greenhouse gas emission to peak by 2030. By the way, this is tomorrow. In many respects, 2030 is very, very close, and to be zero equivalent by about 2050, 2070, depending on the target that you want to have, and depending on the how quickly you can make decision. And the decision that we take, or worse, the decision that we don't take now, will have consequences not only for a few years, but for things like sea level rise for centuries. The cost of dealing with consequences of inaction will greatly exceed cost of action. And I think in this place you got lecture by Jeffrey Sachs to highlight this point on a few occasions. Now, 2015. Let me go back to 2015. That was, in many respects, an exceptional year. There was, at the beginning of the year, a World Conference on Disaster Reduction, and you know many disasters will become more frequent and or more intense because of climate change. And there was a framework put in place how to make to minimize this increase and how to make the planet more resilient. There was in September in New York the adoption of Agenda 2030, the Sustainable Development Agenda, and at the end of the year, the Paris Agreement during the 21st session of the COP, of the Framework Convention on Climate Change. So the pieces of the jigsaw really came nicely together, and that was a very encouraging year. Because if you take first about Agenda 2030 for Sustainable Development, all the 17 goals were defined. The goals cover essentially all the major activities, and if you look at them, you will realize that all of them, without exception, are cross-cutting. So you cannot deal with any one of them in isolation, and suddenly climate change is affecting all of them, or maybe not all of them, but most of them. Poverty, hunger, health, education, and so on. You could go on. So climate change cannot be taken in isolation, but they are cross-cutting. And it defines, it was adopted in a unanimous fashion. Remember, in the United Nations system, unanimous decisions are not so easy to achieve. And often they are achieved at the expense of the substance. That is, you can more easily achieve something with little substance than something with a big, ambitious goal. It is ambitious. So I was very happy that it was achieved unanimously, including any country you think of, any of your country in the room adopted, supported that. And it was ratified in record time in the UN system. In less than a year it was ratified. So very, very... Now, the Paris Agreement, there was also very strong political support. More than 150 heads of states and governments, unanimous again, even though some countries have taken a slightly different route since then. Ambitious again. They keep warming well under 2 degrees and as close as possible to 1.5 degrees. There will be regular review. It has started, by the way, and the objectives, national objectives, cannot be reviewed down. They can be reviewed only up. Actually, USA has announced they will withdraw. They have not yet withdrawn because it's a process. It takes time. They have not yet withdrawn from the Paris Agreement. They've taken a number of decisions which maybe go in a worrying direction, but they have not yet withdrawn. So that was not the end of the road because science, we continue to make research. We come with stronger elements, more solid elements. And one thing member states ask from IPCC was to produce a special report. What about keeping the warming under 1.5 degrees instead of 2 degrees? 2 degrees would be better than 6 for sure, but 2 degrees is already very bad news for a number of countries, like small islands, like coastal countries, for many things. So IPCC took on board this task and produced a year ago exactly a report on this 1.5. Now, the situation is that you have to keep in mind that we have already behind us more than 1 degree. Done, tick. We cannot go back on that one. So, to stay under 1.5, you have only half a degree flexibility. This is not much. The effects are already visible. And at the current rate, 1.5 degree will be reached tomorrow before the middle of this century. So, it's really tomorrow. But, and this is the still encouraging point, the past emissions do not commit yet to 1.5. So we still, technically, we can still achieve it, but it will require very strong decision in a very short time scale. And to do that, and the CO2 emissions have to drop by 45% in 2030 instead of 20% for 2 degrees. So you see, it has to drop much faster. And when I say 2030, it's compared to 2010. This is the reference we use for that. Then they have to reach net zero by 2050 instead of 2070, 75 for 2 degrees. So it means the target is much, much higher. And to achieve that, it's not good enough to limit the emission. It will be necessary to remove CO2 from the atmosphere. And there are not so many processes to do that. So this is a challenge. And the current national commitments right now are not sufficient. The current national commitments are putting us on a course of, I think it's between 3.74 degrees. The current, that's the business. The current commitments are putting us on something which is significantly above the Paris Agreement. We are not yet by far, not on course for that. Then Member States asked other special reports from IPCC. One of them was on food security and land. And the current situation, actually you experience that in Cyprus, is that the land surface has risen nearly twice as much as the global average temperature. When you talk about 1 degree rise in temperature, translate nearly 1.7 to 1.9 degrees over land. So for a very simple reason, actually. The climate change, including the increase in number of extreme events, has already affected food security and a number of ecosystems in many parts of the world. It has contributed to an expansion of desertification and land degradation in many regions. And again, remember, IPCC always provides confidence level. These two statements are with high confidence. Response option, and this is where it's also a positive signal. The response option, of course, they cost money. But at the same time, these expenses should not be considered only as expense, but as investment, because they do contribute positively to sustainable development, they do contribute to other societal goals, they do contribute to minimize health problems associated with climate change, and most of them, when it comes to agriculture and land use, can be applied without competing for land, and they have the potential to provide a number of co-benefits. So again, high confidence in this statement. Another report, which was published literally a few days ago, was the one on special report on ocean and cryosphere. And now I just put a few graphics. Don't worry, I will not go through all of them. I will go through only a few of them. I mentioned acidification of the ocean. I should mention the time scale here is. Let me just make sure that I don't tell you something wrong. The time scale on the right goes to that's okay. The time scale goes to 2,300 on the right. So it is to show you also that climate change is not only for the next decade if you take action, but some aspects, in particular in the ocean, will keep on developing. We are about here. And what you see is that it's getting more acid already, and it will get significantly more acid in a sort of worst-case scenario, and this is the optimistic scenario here. But it will still be more acid than it was before. The level of oxygen, which is here, is also dropping. The extent of the Arctic ice is dropping. Of course, this one is leveling off, because when you have no ice left, you cannot drop any. You cannot go any further down. So this one, the minimum is 0. And no, not this one. So you have also the increase on the top left of the heat content. So you see the ocean is accumulating heat, and it will continue to accumulate extra heat over the next 100 years. You will have a significant loss of the mass in the ice sheets, and very worrying of the permafrost as well. You know, the permafrost is this permanently frozen soil north of Canada, in Siberia, and one of the challenges, if it melts, first of all, it's very difficult to build infrastructure on former permafrost, but in addition, it contains significant amount of methane, which can be released in the atmosphere, and the methane will accelerate the global warming. So, the permafrost is a real worry, and the result of all these things for the sea level is that instead of having a range of about 20 to 65 centimeters expected in the previous IPCC report, this new special report that shows that we are more on track for 40 to 84 centimeters by the end of the century. So this is, in other words, the prediction of the previous IPCC reports were too optimistic. Now we are very worried because the sea level is rising faster than what we expected. What are the challenges? Many, and I could spend a whole lecture, and I will try a big challenge to summarize that in one or a few slides. I mentioned almost all sustainable development goals and other major issues are cross-cutting. It is a challenge because it means that you need to have different communities who are not used to work together, and they need to interact closely with each other. So we need more cooperation across disciplines, across borders as well. We need to take into account long time scale. You cannot just look at what is best for my company, for my country, for myself over the next few years, but you need to look at longer time scale, decades, a century, longer time scale. If you do care about the planet we are leaving to our children, our grandchildren. The past, and this is a real challenge for making decisions, is increasingly misleading as a predictor. Often big decisions, like if you built a dam, the traditional way was to look at statistics and to say, I built that because it was so over the last 50 years, 100 years. Now, and this is true for Netherlands, actually, when you design the dikes to avoid the flooding, you designed that to, I think it was with a protection of about 500 years, but that was based on the statistics at the middle of the 20th century. Now, because of sea level rise, the return period is not 500 years. It may be 50 years. It's certainly much less than 500 years. So the past is increasingly misleading as a predictor. And the decisions, I know there are many high-level decision makers in this room. I'm sure you prefer to have yes or no answers from scientists. But actually, the answers are yes, no, and maybe, probabilities. So decisions have to be made in a somewhat different way. So there was Antonio Guterres, the Secretary General of the UN, convened this climate summit recently, and Cyprus was well represented in this climate summit. I think your president was there, and the messages, some of the messages were not good. The world, as I mentioned, is not on track to meet the objective of the Paris Agreement, by far, not by a small margin. So Antonio Guterres said we need to accelerate momentum. I don't want fancy speeches. I want concrete commitments, to the point that if a country doesn't have that, they were not allowed to speak. So it went as far as that, to say, sorry, we are not going to give you the podium, and some big countries were a bit upset because they were not given the podium. Some others decided not to attend, so they were not refused the podium because they didn't attend. And he says, he welcomes, and I do too, the involvement of young people. You may argue with it, people may have different opinions, but this generation and their future children are the ones who will suffer from what we decide now. So I welcome this. It's part of this dynamics which is increasing, and I think it's good because it's a way to bridge this gap between various timescales, the one linked to elections, to decision in private companies and so on, and the one linked to the future generation. We need to dramatically reduce emissions next decade to reach climate neutrality by 2050, to reduce subsidies for fossil fuels, and the next COP will be actually the first check-in on the commitments made at the summit. By the way, you may know the COP should have taken place in Brazil, and for a reason you may understand, Brazil decided not to withdraw its offer for the COP, and Chile gracefully agreed to host the COP. So thank you, Chile, for hosting the next COP. There was actually not much coverage about the outcome of the summit. Quite a number of things happened in this summit. There were a number of, indeed, concrete announcements. And I don't list them in sort of order of priority or importance. I just listed them in the order in which I got them from the various reports of the summit. Russia decided to ratify the Paris Agreement, which was not obvious. And now Russia has decided to ratify. It's an important decision because it leaves the country who have decided not to do it very isolated. You see, now 187 ratifications, Russia will bring it to 188. It's a big number. So something we feared after the US announcement that it would withdraw from the Paris Agreement is not happening. We don't seem to have a domino effect on this issue. So that's for me very encouraging. 77 countries, a big number again, committed to climate neutrality by 2050. Climate neutrality doesn't mean you don't emit anything. It means that what you emit is compensated by sinks. So, but it's a big number, 77, not insignificant number. 9 countries announced phasing out of coal. It's not enough, but still, it is the dynamics on phasing out coal is now definitely increasing. You probably know Mr. Bloomberg, who has been funding many of these things. He has decided that he will increase funding for phasing out coal to 30 additional countries because he funded many of these actions, including in USA, funding the withdrawal of a number of coal plants in USA. So 12 countries made financial commitments to the Green Climate Fund, in addition to 4 European countries who have recently announced a doubling of their contribution. I'm not going to name the country because if I get it wrong, I may upset those I don't name. But those of you in the room who have been part of that, you will recognize yourself. Now, interesting. There was a coalition of 87 companies, not small companies, companies like Nestle, like big companies, who committed to zero net emission by 2050. Now, the capitalization is over $2.3 trillion. So it's not negligible. $2.3 trillion. If it was a country, you would be one of the major economies of this planet. There was another alliance called the Cool Coalition. It's people who are involved in a cooling system who say we want the cooling system to not to generate become also climate neutral and to be more effective as well. So 80 partners and some of the big names in this thing. The Asset Owner Alliance, very encouraging news. Essentially an alliance of pension funds, of insurers, including, by the way, the United Nations pension funds and New York pension funds and a few others, have committed to move their portfolio completely away from carbon investment by 2050. And their portfolio, again, is over $2 trillion. So this is not going fast enough. This is not going far enough either. But it is moving in the right direction. And there were a number of initiatives launched, including, of course, it's important, the Cyprus Presidential Regional Climate Initiative. And the role of this institute will be critical in this initiative. And the launch of EMICARE goes exactly in support of that. So a few remarks, and I hesitate to call them concluding, because this story is not concluding. Time is really of the essence. The traditional market forces, often you hear about market forces, they are not enough. They are even not appropriate in many cases for that. So we need to have a long-term approach and to forget about this problem, talking about carbon tax and some people get allergies when we talk about tax. So I don't care, I'm not an economist, I don't care how you call it. But what I know is that we have to put a price on carbon. A realistic price which takes into account everything. There may be different ways to do it. I'm not an economist, I'm not advising how to do it, but we have to put a price on carbon. We need to have a global strategy for key sectors, energy, transport, industry, agriculture, not only to have this approach country by country. We need to have global strategy. And Agenda 2030 for Sustainable Development definitely goes in the right direction. We need to look at responsibilities, the current and future responsibility. Actually, Madam Ambassador, in your own country, there was already a legal action against the government for not taking... so I suspect this kind of thing will happen more frequently. I'm not judging, but it will happen more frequently. There are ethical issues. What we do, it cannot be considered just by looking at what is the interest for my own country. We have to look at the global picture, at the global... There's an ethical issue which has not really been addressed. And we need to include all key actors. Government, of course, that remains important. I'm a strong advocate of the intergovernmental system, of the multilateral system. At the same time, we need to get the other actors on board, the civil society, the region, the cities. Look at what happens in many countries where, if I take USA as an example, there is a very strong difference between the approach taken at federal level and the approach taken at individual state level, or even in some cases city level. New York City made a commitment to become climate neutral, one of the first big cities to become climate neutral. So we need to involve all these things. And of course, let's not, of course, the scientific community, not because I'm here in the Cyprus Institute, but I believe the scientific community has a very strong role, not to make decisions, but to advise decision makers to give them the best possible information so that they can make the best information. No country can do it alone. Sorry. if some other people say that, I'm sorry, I feel adamant about it. No country can do it all. The multilateral system is absolutely essential. You cannot deal with climate change in the same way we cannot deal with weather things just by a number of bilateral agreements. Not possible. Every country is involved. If you have about 180 countries, just imagine, multiply 193 by 194 divided by 2, you would need a bit less than 20,000 bilateral agreements. It cannot work. It has to be a multilateral approach. So, you have choices. We have choices. We have a good choice. We have a bad choice. We have the knowledge. Ignorance cannot be taken as an excuse for inaction, and there is urgency to act. Thank you very much. Efkaristo.
Thank you, Dr. Jarraud, for this very interesting lecture. We will now open the floor to questions. We'll take the 2 questions at a time and then move on to the next 2 questions. So please, yes, microphone, please.
Hi, thank you for your informative lecture. I would like to get your opinion regarding the extraction of natural gas in Cyprus, because it's often sold as greenwashing from our government that yes, it emits less than mazout, which we're currently burning, but it's still a fossil fuel. And isn't it kind of hypocrisy for our state to say that we want to have an initiative for climate change, but at the same time to want to be at the top producer of natural gas? Because natural gas is not going to only be used by Cyprus, but to be sold to the rest of the Middle East. Thank you.
Thank you. Yes, next question.
Congratulations for your excellent and alarming presentation. Now, being a Cypriot living in Nicosia for the last 50 years, not only temperature has been going up, but I assure you, and this is evidence personal, that humidity is also going up. Why?
You see, the beauty of lecturing here for the last question is that you have experts in the room who will be able to give you more precise answer than I can. So I'm sure the colleagues of the Institute can give you an answer. With respect to the other question, actually, this is an interesting question. This is an interesting question because you can see gas in different ways. Gas, if it's used as a sort of temporary thing to replace things like coal or something, indeed, it can be cleaner. The other thing is that you can, and I should have mentioned that, to meet the targets, you need not only to reduce emission, but you need to probably you need to capture some carbon. So it really depends how you are going to do that. If it's done with capture of the CO2 emission at the source and storage in one way or the other, that would be a different thing than if things are emitted in the atmosphere. So the cost would not be the same. There's a cost to that, but one has to look at the whole process. Actually, this is why it's a very complex issue. When I know there are a few journalists in the room, media people in the room, one question I'm often asked when there are things, it was not today, by the way, but I'm often asked is, if there is one thing we can do, what would you advise to do? And often I refuse to answer this question in that way because I say, if I was to answer that question, I would give a misleading answer. Often with climate, it's very difficult to, you want to, and this is the challenge of communication for us. There are very difficult answers where things are interacting. You have to look at the whole process. Take another example. It's only good to encourage electric cars. Well, yes and no. It depends how electricity is produced. If you produce electricity with a coal factory, I don't see very much of the benefit. And then you have to look at the whole time sequence. For electric cars, you need batteries. You need to recycle. You have a whole process. One has to look at the whole thing. I still believe that it's a good thing to do, and that's what I'm doing personally, to try to do as many things as possible. But at the same time, you should not look at something in isolation. So as I say, for gas, it depends how the gas is being used, because you are still going to need a little bit. When we talk about carbon neutrality, as I said, it doesn't mean that you emit no CO2, but it means that what you emit has to be compensated by what goes into the ground. So that's why I'm very, and then you have to look at the context of every country to look what is the context. Yes, sorry, there are other questions you want to.
Yes. Yes, the lady.
Thank you for your talk. It was very informative. I would like to ask you a question. So, Cyprus obviously is a small country compared to USA or China. And people here are skeptical too about climate change. And so, if I try to talk to some people about it, they'll say, oh, we're Cyprus, we're so tiny, we can't do anything about it. Look at USA, look at China, what can we do? And if I like try to convince them with facts and science like you did today, they will say, okay, well, we can do that, but a little bit, you know, let USA do it or China because they're the big guys. And how would you reply to a person who says, oh, we're tiny, we can't do anything about it, or we will do a little bit, not the full thing? Thank you.
Thank you. Another question? Yes.
Well, at some point in your talk, Dr. Jarraud, you underlined the word removal of carbon dioxide, if I'm right. Have we reached the technological stage at which we can be, there is some hope in this direction of achieving this technologically removing carbon dioxide from the atmosphere?
Yeah, okay, maybe the first question, and then I will come to yours. The first question about, indeed, I've been through this argument on many occasions. People say, okay, but if I do something personally or in a small country, it will not have a big impact globally. Of course, you have to remember that we have about 7 billion people on this planet, and 7 billion means 1 + 1 + 1 + 1, 7 billion times. So small, we have an expression in France, les petits ruisseaux font les grandes rivières, small streams end up in big river flows. So we should not underestimate the importance of individual action, because even in China, you could say, an individual in China say, okay, I understand it's important for China to do something, but if I do something myself, it will not change what China. No, everyone has to make efforts on that issue. And some of the action are not only at the individual level, some of the action have to be at the company level, some action have to be at the government level. You cannot select only one thing. We cannot solve the climate issue if we don't tackle it from many complementary angles. Now, for the second question, well, we have been discussing that on on quite a few occasions. How can I? Okay, maybe Silas, I would prefer to go into much more detail with you in a sort of private discussion on that one, but I don't disagree. It's
Yes, please.
Hi, thanks for the lecture. It's really very good. I'm curious to know what you think about trying to make the changes that that we all are interested in seeing made. Also, the global goals table. I thought that was really very interesting. When you think about this, don't you imagine that the economic system, the economic model that we use now, might have to make some changes, where you have essentially shareholder capitalism that is looking to turn a profit every quarter, that is looking for continuing growth, that's always wanting to expand into new markets. And I think that what I get from reading about this controversy is that companies are reluctant to do this because it's going to cut in their profit margins. And so that's why you can't really get them behind it. So I was wondering, I assume that you've thought about this considerably, so I'd like your thoughts on that.
Okay. Yes, on the similar issue, because okay. So in this case, maybe I will answer directly this one on the economic aspect. There are several elements in my answer to you. The first element is that it's already quite difficult to make climate prediction. Of course, economic prediction are challenging as well. What will be the state of the economy in 50 years, in 100 years, is a big challenge. And for a long time, the physical science, the physical climate science community and the economic science community have not really been interacting very much. This is changing. But now back to the core of your question. It is true that a number of companies, the way they optimize their modus operandi, the way is incompatible. Actually, I mentioned there was one line in my presentation to say some of the current market approach are inappropriate for dealing with climate change, because indeed you cannot deal with climate change if your operation is driven by very short-term consideration. What is the return over the next few from nanoseconds? If you talk about currency exchange to weeks or months or possibly just a couple of years, if you talk about a number of companies, it's not compatible with dealing with climate change. However, I would not put all companies in the same thing. Some sectors have already experience of considering longer time perspective. For example, if you build a dam, and you have built quite a few in this country, you normally don't consider only the next few years, but you would like to know what is the likely situation in 20, 40, 50 years. A dam is here to stay for up to, well, it can be more than 100 years. So some sectors, and I mentioned the water management sector. I could have mentioned the energy sector. When you build an energy plant, the life cycle of many plants is 40, 50, 60 years. So several sectors have this long-term consideration. Insurance, and in particular the reinsurance sector, has really a long-term perspective. Not all sectors, and you are quite right, some sectors just look at very short-term things. So the idea is to encourage more of this coalition. I mentioned as one of the outcomes of the climate summit organized in New York a few days ago, the coalition of big companies. Because, you know, the big companies, they do it for a number of reasons. Many of the big companies want to survive for a long time. So they have a long-term perspective. At the same time, they do care, and it is under the pressure of the outside to a large extent, about their image. And what's happening now is important as well, because several of them don't want to face a sort of boycott type of action, and it's introducing factors which are forcing them to have a longer-term perspective. The last point, I've myself been, when I was Secretary General of the WMO, almost every year, as part, by the way, of the General Assembly of the United Nations, the Secretary General was organizing a debate between the private sector and the UN system. And as part of this debate, I interacted with a number of leaders of big companies, and their message was very interesting. Their message was actually, we don't mind having stricter rules, having stronger regulation, but what we do want is to have visibility. We don't want these rules to change too often, and we want the game to be fair. We want that we all play with the same rules. So they say, actually, we don't care even if you put a tax on carbon, but we want the rules to be clear and predictable. The last thing I want to mention, and that's, I should say it's encouraging, you have heard about the World Economic Forum in Davos every year taking place. Every year, in preparation of the World Economic Forum, they produce a report, a big report, where they evaluate, amongst many other things, what are the the perception by these top-level decision makers of the biggest risk for the world economy. Now, in the last report, which was published in January this year, if you have looked at it, very interesting. For the first time, out of the 5 top risks, 4 of them were related to climate change. 4 of them. So it means that the biggest companies and decision makers realize that failure not to take climate change on board is actually not only a risk, is the biggest risk for their company. So this was different 20 years ago. But now, every year you could see a progression. 3 years ago, the failure to take climate change into account was the top risk. The year before, it was risk number 3. It was very high. But now, this year, out of the top 5, 4 of them are climate-related risk. So this is, again, doesn't go fast enough, but for me, it shows a change in the attitude. So, yes, you wanted to... Of course, he knows everything about what I said. He even contributed to it.
Thank you for this inspiring presentation, Michel.
Yeah.
I thought I might want to help with the question on the humidity.
Ah, good.
Because that is actually a very relevant question. When you warm the system, of course, when you warm the ocean, you have more evaporation. And if you warm the air can contain more water. And if you put these things together, you have a non-linear system, which means that the amount of water that gets into the atmosphere is increasing rapidly. Actually, a 1 degree warming in climate means a 7% increase in humidity. And this is not only because it's interesting because it affects the water cycle, but it also has to do with the fact that water is a very potent climate gas. And this is one of the reasons why the climate is changing so rapidly, is that it also gets more humid. Water vapor is an important climate gas, which accelerates the effect of carbon dioxide. So I think it's a very important question and very relevant.
Thanks. Yes.
Any more questions? It's Vasilio.
Thank you.
We are hearing in the last few days about the danger of the breaking of a part of the Mont Blanc, a glacier of Mont Blanc. Is how imminent the danger is, and what will be the repercussions in Europe in general, not only Switzerland.
Yeah, actually, glaciers are melting not only in Europe, even in other land glaciers in the Himalaya, in the Andes. Most glaciers are retreating. Now, when the glaciers melt, there can be some direct effect. Of course, if a big fraction falls on a village or things. You can have another very dangerous effect is under the glacier, normally you get accumulation of melted water, which is still retained by a little dam, which is rocks and something, and suddenly it can burst. And you can get these flash floods, which can be incredibly dangerous. It's a big problem. I think the director of the French Institute was before posted in Nepal. It's a huge problem in Nepal because you get this melting and this risk for many villages where you can get this water. Now, in the Alps and in the mountains in general, much of the mountains, the rocks, the glue for the rocks is actually frozen water. It's ice. When it warms, you get more of these rocks falling. Actually, in the place where I'm living now in Switzerland, it happens now more frequently. Very serious accidents have happened because of some of these mountains just collapsing and big rocks falling. They were previously glued by the ice, and now you get more of these rock slide, as they call it. So it is going to be an increasing threat to some of the villages in just under this glacier. Yeah, it is a problem, a serious problem. But thank you for the question.
We will take one last question, if any. No.
Thank you.
Dr. Jarraud, thank you once again. It was an honor to have you here with us tonight. Thank you all for being here with us tonight. Please join us for a reception at the foyer. Thank you.
very good professional. Interesting, I didn't see the title. It's my subject. Yeah, but you see professional communication.